Hello everyone, I am Feyza Özgün from Istanbul Technical University. In this research, we studied collaboratively with Associate Professor Dr. Sema Alaça, and the research we present is about exploring the use of augmented reality in the design process in terms of user interfaces and interaction of the designers. The aim of the study is to evaluate the user interfaces that reflect different interaction layers in the context of augmented reality technology. Depending on the physical characteristic of human interaction with the computer, these layers were examined under 4 sections: graphical user interface, tangible user interface, natural user interface, and spatial user interface. The use of AR-based applications in the design process provided the basis for evaluating the user interface in these interaction layers. The transfer of architectural knowledge in terms of the designer's intention and the design can gain a new perspective with not only the cycle of sketch, 2D CAD drawing, and 3D models, but also human-computer interaction in the direction of new technological innovations. Interfaces developed to examine the interrelation between designer and design in the frame of physical representation and digital information provide a reinterpretation of the interaction through concepts such as immersion, interactivity, haptics, augmentation, and simulation. A proposed AR application interface has been developed to bridge the physical and digital environment. The system allows the user to interact physically with design thinking and offers an area where natural gestures and real environment support the design in the digital environments. The term interface provides reciprocal communication as a feature of the SS. Interfaces facilitate human-computer interaction by enabling computers to communicate with the physical environment through controllers and displays. The most commonly used elements for a graphical interface are the icons for functions and applications, the windows where the icons are displayed, the menus and marking tool used for selection. Tangible user interfaces provide digital information to a physical object used for control and display and establish a computable relationship between them. AR and 3 interfaces can be used together as a new method to eliminate the distinction between real and virtual that can be named tangible augmented reality. In the new concept of the integrating naturally with the technology, interaction forms such as speech and view comes to forefront instead of mouse and keyboard. Lastly, within the scope of the user's spatial perception and awareness, the movement within an area can be defined spatially by using spatial user interface techniques. This creates a more user-focused, intuitive experience than switching between tabs on a single digital screen. Within the scope of this study, starting from the interface concepts, the GUI interface on the tablet and the 3D model in the real world are supported by the interaction of the designer with the model spatially. One of the most important features that make the application different is the use of 3D object scanning data as the marker recognition method required for AR. The digital components based on the platform of the application used in the study are Unity and Vuforia. In the application interface, the main menu panel is displayed when the physical model defined as the database is scanned in real time on the AR camera. There are 4 menus under the main menu panel: Generate, Modify, Inform, and Animate, and each menu has its sub-menus. Within the scope of the menu contents in the application, basic arrangements such as creating basic geometries, cubes, spheres, cylinders, adding digital models, ready for the scene, and deleting unwanted geometries can be made. In addition, color, size, position, and also moving, resizing, rotation functions 3D objects added to the screen by taking advantage of possibilities of the AR environment can be created on the application. To evaluate the use of the application in the early design stage, data were obtained in the line with the positive and negative feedback on the current state of the application, the case study. The case study carried out is based on the experience of 5 students who created an alternative to the given mass settlement program using to develop the AR application and the physical model. In this context, the math settlement program requested by the students consists of 4 units dormitory, a 2 units cultural center, a dining hall, and a sports area. In the design process, the interaction with the physical model was observed in 2 ways. One is the participants changed their own position around the table by moving. The other way is for the participant to change the position of the model by touching the physical model. During the design process, the participants exhibited behaviors such as bending around the table, examining their designs by holding the tablet in line with the model in a horizontal plane, or changing the position of the tablet according to the physical model. In the graph above, the frequency of the changing their own positions and the position of the model in the interaction of the participants with the physical model is shown. And the graph below is shown that the evaluation of the application functions and the interaction with the physical model. Participant P1 requested feature being able to zoom in the image application. This 3D scanning process of the tablet with the AR camera of the tablet is interrupted in the position where it gets too close to the physical model or too far from the model. Participants stated that they generally focused more on using functions in the application. For AR, ensuring continuous connectivity of scanning has been challenged in this regard. However, 3 participants stated that they often felt need to rotate physical model. 3 users mentioned the need to rotate around the table, mostly changing their own positions. Within the scope of the study, AR-based user interface proposal was evaluated. The advantages and limitations of an integrated interaction model, where designers interact more naturally with graphical and tangible user interfaces, are explored. The AR-based GUI is also supported by the real physical model, offering an area where the user can interact physically. This bridge that the GUI builds with the physical model creates a powerful, tangible augmented reality example for users. This work is not yet supported by different natural interactions, such as voice and gaze interaction. However, it has the potential to add new functions to more natural interaction in the future stage. We believe that studies in this field support interfaces in allowing a more natural interaction. In this sense, our work is an exploratory work on this path and supported by GUI, TUI, and partially SUI approach. As a result of the evaluation data obtained by testing by application users, it's thought that use of AR environment in the design process will contribute positively to design in terms of interacting with the physical and digital environment together. In the next stage of the study is aimed to expand the case study on the use of the application in design process and the evaluation of the developed functions. It's planned to expand the case studies to be able to evaluate the user interface, usability, and performance of the application. And still the reference list, and thank you for your attention.